Talking about misleading graphs, and the thing is that one, you need to be able to recognize if a graph is misleading, but you also need to understand that sometimes companies make the graphs purposely misleading because they want to influence you. They want you to see something that maybe really isn't there, but they want to make it look like it's there, okay? All right, in this first one, this is talking about website hits, and you guys all do like Instagram and see how many hits that something gets or likes or whatever. So this is looking at the number of hits based on whatever month it is. And it says you record the number of hits for your school's new website for 5 months and tell whether each data display is appropriate for representing how the number of hits changed during the 5 months, and explain. Well, in this first one, this is appropriate, okay? So this is not misleading, because we can see that the scale, and that's always what you want to look at, these intervals. The intervals are by 200. Can you see that? 200, 400, 600, 800, 1,000. We can see that each month is represented, and we can see that the bars are all the same size in terms of their width. So from here to here is all the same. So this is appropriate, because we have a bar for each month and all the widths are the same. Versus, this is the same data, but it's represented in a different way. This is your website hits. And again, we're supposed to be able to tell over a 5-month period. When we look at this one, we see that it's showing the frequency of the number of hits in what range, but it's not appropriate because there's no data. It's not organized by months. It just lumps them all together into the category of how many hits there were from the 0 to 399, how many hits in the 400 to 799. But this is misleading and not an appropriate graph, because we're missing. We're trying to tell what kind of change is happening over a 5-month period. All right, this last one that we're looking at, same information. In August, we can see that it was a little over 200. In September, it was close to 400. In October, it was over 400. In November, over 600. And in December, it was almost 1,000. So this is appropriate. And it's evenly, the intervals are good. So we can see that the intervals are all the same. They're by 200s, and we can see that each month is represented. All right, let's go to the next page and look at a graph. And we're going to compare. So this is showing us 2 different graphs. And one of them is trying to mislead you, okay? This is looking at through the years and the revenue of, and it doesn't say what, but box office. So movie revenues through the years. Sorry. My mom ended up in the hospital again over break, and I got to be looking for the doctor calling me. So we're looking at which is misleading, and it's the box office revenue. So let's compare. For both of them, the interval for the years it's showing is the same, okay? When we talk about the revenue, if we're trying to show that we had a big increase in revenue, we can see that this graph A looks like there's a big increase in revenue versus graph B that's kind of more static. So when we're looking at the two and we're trying to see which one is misleading, do you see this little broken axis right here? Because it's broken, we're starting at 9, and then we're going from 9 to 10 to 11. So we're going in intervals of $1 billion. You need your guided notes packet out. Whereas over here, this is by 2 billion, 4 billion, 6 billion, 8 billion, 10 billion. So this one has all the information there. My intervals are all the same. But here we have a broken axes, and therefore the intervals are uneven. So this graph A is the one that's misleading. But the box office might want to use graph A because it makes it look like there was a, the revenue went down for a bit, but then it went right back up. And it makes it look more dramatic, as opposed to this is like the revenue's not changing all that much over a period of time. Okay, let's take a look at the second bar graph. And this is what you're going to have to do on your test on Wednesday, is you're going to be looking at two graphs. You're going to have to tell me which one's misleading, and you're going to have to tell me why. And the big things to look at, and your answers, are going to either be that you have uneven intervals, like this one. The intervals are uneven because it made a jump from 0 to 9 here, and then after that by ones. Or if you look at this second one, this graph is misleading. When I look at the two graphs, graph A and graph B, we notice that the years 1, 2, 3, 4, 5, those are all the same. We notice that the intervals 5, 10, 15, 20, 25, those are all the same. But something's different. One of them is misleading. What is different? It's all the same information, but is graph A or B misleading you? We're talking about the profit, the company's profits. Notice this bar right here for 5. Do you see that? See its width? Same width as 4, same width as 3, 2, 1. Do you see they're all the same width? Go over here. Same. Ooh, that's a little bit bigger, isn't it? Look at this one. A little bit bigger. Look at this one. So they've made it misleading because the width of the bars is different. They've made it bigger each time. And so they're showing the same information, but they're making it look like it's considerably bigger because they've made the bar bigger. So they're just trying to confuse you. This last one. The organizer of a food drive creates the pictograph shown. A volunteer concludes that the number of cans of food and boxes for the food drive donated were about the same. So they're looking at cans, canned food, and box food. And when they look at it, they're like, yeah, it's about the same. Is this an accurate conclusion? If you look at the picture, and that's all you look at, they do look like the number of cans and the number of boxes are the same. But if you go down here, each can represents 20 cans. So when I look at my cans here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 times 20. This is really representing 220 cans. a box represents 20 boxes, okay? And I have 1, 2, 3, 4, 5, 6 boxes. 6 times 20 is 120 boxes. Are they the same? Not even close. But picture-wise, they look the same. What did they do to make them look the same? Yes. Yeah, the size of the box is larger. So one box, this box right here, is much larger than one can. And remember, this represents 20 cans, this represents 20 boxes, but they made the boxes bigger, so it's misleading. And then when we look at juice, we see that we have 2.5. So if I take 2.5 and I times that by 20, I have a total of 50 juices. So when I look at it, because of the size of the pictures, they're making it look like cans and boxes are the same, but they're not. And so they just misled you. And they can say, well, I have the scale down here. You just had to do the math. But do most people do the math? They look at the pretty picture and they go, oh yeah, we collected just about the same number of cans as we did boxes. But that's not true. We collected 220 cans and 120 boxes. They're most definitely not the same. All right, so we're going to be looking and interpreting graphs today. And the first thing we're going to do is practice on a worksheet. So I'm going to pass your worksheet out to you, and you want to make sure that you have the correct side. Yeah, that would be lovely. I would really appreciate that. So when you pass it out, you want to first make sure that you have the correct sides, because side 1 and side 2 look very much the same. And if you'll put your name on this and make sure that you write side 1, and make sure that side 1 is the one that is talking about, well, it's the graph that looks like this, where they're talking about workers. So look for that word so that you have it in the correct side, and mark side 1, because when you come to grade, you'll get confused if you don't have it marked. Are you literally just going around to every single person? No, go for it. That's fine. No, that's fine. All right, if you'll make sure and put your name on your paper and write side 1. And I'm going to help you because I'm going to read to you, but you're going to have to then circle. So you're going to have to listen. Okay? All right. And then you're going to come and grade this. All right. For the first one, these two graphs represent the same pieces of information. It says the line graph. Which line graph would workers prefer to show so that their wages appear that they have not increased that much over the past 4 years and they deserve a big raise? So if you're a worker and you're trying to tell your boss, hey, look at this picture. Our wages have not gone up. We deserve a raise. Which graph, A or B, shows wages not increasing over 4 years? If you think A, raise your hand. Very good. A, because it looks like it's pretty much a flat line. So if you're a worker, this would be a good graph to say, hey, we haven't had an increase. Now, which line graph would a company prefer to show so that it appears that your wages have increased substantially and you do not need a raise. So looking at the two graphs, you're the company and you're like, hey, you don't need a raise. We've been increasing your wages every year. Is that graph A or graph B? And you circle the one. And I'm not doing that with you. You're doing it on your own. We're looking at which of these two graphs, A or B, a company says, you don't need a raise. We've been giving you a raise every single year, and they've been going up a lot. All right, let's take a look at your third one. Both graphs say the same information. Okay, it says, which line graph would a school prefer to use to boast about their SAT test scores and saying, hey, they've really increased from last year? So between the two graphs, a school is wanting to show that their SAT scores have really increased. Circle the graph that shows which graph shows a big increase in SAT scores, A or B, if you're wanting to say we've had a huge increase in scores. The last one on this page, which bar graph of metals 1 gives the impression of a great disparity and would be the one that Norway might prefer to show as far as metals? So you're Norway, here's Norway, and Norway wants to show that, you know, obviously in both graphs they had the most number of metals, but which one shows the biggest disparity, biggest difference? If they want bragging rights and they want to say, look how much more we had than, say, the United States, okay? We want the one that has the biggest disparity. Disparity is like difference that shows it. All right, now we're flipping over to the back side. And each time you should be circling. On this side, you're going to write side 2. All right. Which bar graph of pollution would the mayor in city X, so we're looking at city X here, and this is showing pollution. Which bar graph of pollution would the mayor in city X prefer to show so that his city doesn't seem that much dirtier than the cities Y and Z? So you're the mayor of city X here, and you want it to look like your city's not super dirty compared to the other cities. So which graph are you going to have them show? Graph A or graph B? So not that much dirtier. So you're looking for the graph that doesn't show a big difference. Okay. Second one. Which bar graph of pollution would the mayor of city Z, so now we're looking at the mayor here, which one would he want to show because it makes his city appear 4 times cleaner than the other two cities? Okay? If you're the mayor of Z, okay, and these are showing how much pollution you have in the city, and you want to show that your city has a lot less pollution than the other two cities, are you going to choose graph A or graph B? The third one, which line graph of lunch detention slips would you prefer to show your parents to make them think that your behavior has been rapidly improving? So this is showing how many detention slips. So started out at 8, ended up with 6 in both graphs. But one of them makes it look like you've really been improving and that your number of detention slips has gone down greatly. And you're like, I'm really doing a much better job, not getting so many detentions. Lastly, which data display shows that girls read twice as fast as boys, but without misleading the viewer? So boys 100 words per minute, girls 200 words per minute. And you'll notice boys 100 here, girls 200. They both say the same thing, but we want to know which one is not misleading. Which graph is not misleading? All right, let's go back through and take a look at it. On this first, or just start right where we're at here. Can you see that a boy, this picture of the boy, it's supposed to be twice girls, but about how many circles do you think you could fit inside the girls there? Yeah, at least 3 or 4 circles. So it's making it look like girls read 3 times more than boys. Really, actually, with all that space, it's about 4. So in terms of misleading, this graph A, this is misleading. So if you're choosing the one that's not misleading, you should have chosen B. In this next one, if you're trying to show your parents that your behavior is rapidly improving, are you going to choose A or B, everybody? Which one shows the detention slips going down quickly? A, yeah. Here, if you're the mayor of Z and you want to say, hey, my city rocks, we don't have nearly as much pollution as the other cities, are you going to choose A or B? B, because it's like, hey, look at my city here. We're so clean. Look at this city. You're so dirty. At this one, if you're like mayor of city X and you're like, hey, we're just about the same as all the other cities, which graph, A or B? Mix. Yeah, A makes it look like they're almost all the same. Okay, on the front side, we did A together, right? And we said in A, this is the one that shows that there's not that big of an increase over 4 years. This looks very dramatic. What I want you to see is that the information is the same, but when they mess with the intervals along the side, it can skew it and make it look different. All right, which line graph would a company prefer to show so that it looks like you don't need a raise? A or B? Which one looks like I've been giving you a raise every year? Jack? B, yeah. Like you don't need a raise. Look, every year it's going up. A school is showing off their SAT scores and they want to say, look at how much we've improved. Are they going to use graph A or graph B? Look at how much they've increased. B. B looks like a dramatic increase. But notice, because you're going to have to on your test tell me why something's misleading, it has to do with the intervals. This one started at 600 and went in intervals of 300. This one started at 1150 and went at intervals of just 20. It went up by 20 each time, so it made it look more dramatic than it really was. Lastly, this is about medals, and if you're Norway and you want bragging rights to show that there's a big disparity between you and the other countries, are you going to choose A or B? B, because it looks like, man, we got double what the United States got, but that's really not the case. All right, today you have an assignment in Delta Math of the work of assignment number 27. So you're going to go to modules, you're going to click on assignment number 27. Your homework, I will have somebody come around and collect your paper, make sure your name is on it. So Madden, how about you do that since you like to go around by the desks?